In this video, we want to derive the expected price in a second price sealed bid auction. To do so, let us first have a short recap. The pricing rule in a second price sealed bid auction is that the price is equal to the second lowest bid. Furthermore, we know that in equilibrium, suppliers should place a bid that is just equal to their cost. So next, what we want to do is we need to know what the probability, or to be precise, the relative likelihood is that the second lowest cost are exactly x. And we denote this density by f2 of x. Okay, so f2 of x denotes the relative likelihood that the second lowest cost are exactly x. Now we want to determine the expected price in a second price auction. The expected price in a second price auction is equal to what the bidder with the second lowest cost bid, namely beta sp of x, times the relative likelihood that the second lowest cost are exactly x. In the next step, to get here, we use that in equilibrium, the bid is equal to the cost. That means we can use this identity. And then we use integration by parts to get from here to here. Remember, integration by parts is the reversal of the product rule, and the product rule says that u times v derivative is equal to u times v prime plus u prime times v, and we can then rewrite that as u times v prime is equal to u times v prime minus u prime times v. If we set u is equal to x and this is equal to v prime, then we get here u times v, and here u prime, which is nothing different but 1, times v, and get this expression. Now, to get to the final stage, the final line, what we need to do is we need to plug in the upper and the lower limit. If we plug in the upper limit, we get 1 times the probability that the second lowest cost are smaller than the highest possible cost of 1, and this is 1, minus 0 times 0, which is 0, so we get that the upper limit is 1 minus the integral. Next, we want to further simplify this expression, and to do so, we will make use of the fact that the probability that the second lowest cost is smaller than x is nothing different than 1 minus the probability that all suppliers have costs larger than x minus the probability that one supplier has cost smaller than x and all the remaining n minus 1 suppliers have costs larger than x. We split up this integral into 3 different parts and try to further simplify the expression. The integral from 0 to 1 of 1 is nothing different than 1. So this integral and this one cancel out. And so what remains are these two expressions. Next, what we do is we integrate this expression, and we find that the integral of this expression is minus 1 minus x to the power of n plus 1 divided by n plus 1. You can easily check if you take the derivative of this expression. And we kept this expression here just untouched. Next, what we do is we plug in the upper and the lower limit. If we plug in the upper limit here, so 1, then this term is just 0. And if we plug in the lower limit, 0, then this expression here is just 1. As we subtract it, we get minus times minus is plus, and so this here is equal to that expression. And we just carried over these two terms. Now we want to simplify this expression further. How do we do that? We do integration by parts. Integration by parts is nothing else than the reversal of the product rule. And remember, product rule is u times v prime is equal to u times v prime plus u prime times v. And as a consequence, we have u times v prime is equal to u times v prime minus u prime times v. If we say x is equal to u and this expression here is v prime, then we get u times the integral of the expression above minus u prime times v, and that is exactly what we have here. What we do next is we plug in the upper and the lower limit. What we find is if we plug in the upper limit, we get a 0 here, meaning the expression is 0. If we plug in the lower limit, we have a 0 here, meaning the entire expression is also 0, meaning this here is equal to 0. So what's remaining after cancelling out the ends is just this expression. And here, for the second part, for this here, it's easy to get to the integral. The integral is given by 1 minus x to the power of n plus 1 divided by n plus 1. And now, finally, we plug in the upper and the lower limit. What we get is when we plug in the upper limit, this expression is 0, so it cancels out. If we plug in the lower limit of 0, then this is 1, so we get 1 divided by n plus 1, and have 1 divided by n plus 1 plus 1 divided by n plus 1 is equal to 2 divided by n plus 1, meaning the second